So today's topic is all about the tolerances, dimensional tolerances. So let us start. Now coming to the next point, that is stack-up tolerance. And these are also one important parameter where generally questions are asked during interview. So stack-up tolerance is basically assembly tolerance. So let us understand this concept by a very simple example. Here on the screen, you can see there is one arbor or a spindle vertical part you can see on the screen. And at the left side, you can see there is one part. Thickness of this part is 20 plus minus 0.1 mm. ID is given, that is 10. And imagine 5 such components you have to assemble on this particular arbor or spindle. So when you assemble 5 components side by side, the total length you are getting is 100 mm, right? Now, what is that tolerance you are getting on that assembly? My question, when you are assembling 5 components on this arbor, the assembly length, the dimension will be 100 mm and the tolerance of that assembly will be plus minus 0.5, right? Now, if I want that assembly tolerance as plus minus 0.3, that is called as a stack-up tolerance. Getting my point? Stack-up tolerance means assembly tolerance. Now, my next question to you, how you are going to achieve this? What is that methodology or what is that procedure you will achieve this tolerance value? Got my question? If the assembly tolerance is plus minus 0.5, but as a design engineer's intent, I want plus minus 0.3. That is a stack-up tolerance. So how I am going to achieve this? Right. So friend, there are various, we can say, answers. What we have to follow is called as a selective assembly. Selective assembly means what? Suppose the drawing is released for production, that is earlier drawing, and during production, some components like the tolerance value is 20 plus minus 0.1, right? So some components you will get 20.0, some components 20.05, some components 20.1, some components 19.95, and 19.9 also is also acceptable, right? So during production, there is a system where there are different beams are there, and if that quality engineer is getting 20.0, he will put that component in a particular beam. If it is 20.1, separate beam. Means you have to differentiate the components as per the tolerances. Now, when you are going for assembly, select 2 components from 20.0, 1 component from 19.95, and 2 components from say 20.05. And when you will go for the assembly, you will achieve that value, that is plus minus 0.3. Getting my point? This is called as a selective assembly. So without doing any further operation, you can achieve this value, that is selective assembly. So this is one important question generally asked during interview. Then the next concept is interchangeability. Interchangeability, we know that any component selected randomly can be fitted in any assembly, that is called as interchangeability. So for example, standard components like a bearing, the tolerances are provided on the bearing in such a way that any make bearing can be fitted in any vehicle. Now, types of tolerances, there are 2 important types of tolerances, dimensional tolerance and geometric tolerance. So unilateral tolerance, this is a very simple example you can see on the screen. There is one dimension 525 plus 0.1 plus 0.2, that is plus plus or minus minus is called as a unilateral tolerance, means one side tolerance. Now here I want to ask you one question. If this is the drawing and if you produce a component with 25.0, will you accept this component or will you reject this component? My question, suppose you produced a component and you got the value of 525.0. When you check that component, will you accept that or will you reject this? You have to reject this component. Why? because it is acceptable within the zone of 25.1 and 25.2. This is again a twisted question generally asked during interview. So unilateral tolerance and second is bilateral tolerance. Here you can see the example 25 plus minus 0.25. So when plus and minus comes, that is called as a bilateral tolerance. But here friends, one important thing, as I already told you, that when you see any tolerance value, it is not just the tolerance value. You have to imagine, you have to visualize how I'm going to produce this component, which is that manufacturing process. So most of the times you will find when you are providing tolerance to a particular hole, it is unilateral tolerance. Have you observed this? And why it is like this? I'll give you a simple example. Suppose you are in a workshop and there is one plate and you are going for a drilling operation, 510 hole you want to produce. Imagine, when you are producing the hole of 510, you must have seen that when you check that hole, it is generally plus. And why it is like this? There are various reasons. One reason, there are vibrations. Second reason could be spindle run out, machine inaccuracies. There are various reasons. So you are going for the hole basis system. And when we say hole basis system, means the hole is constant and you are changing the shaft. But it doesn't mean that there is no tolerance value on the hole. There is a tolerance value. But in case of hole basis system, you must have observed that the first value of that tolerance is 0.000. So providing the tolerance is not that much important. What is the most important factor here? What type of fit you are going to achieve?